Good day. I'm glad to have you here today. In today's class, we are going to be looking at two problems using the problem techniques in my previous video. Example 1. A car travels a distance of 120 km in 2 hours. Determine the average speed in 1 km per hour, 2 in meter per seconds. Given data, distance S is given as 120 km. Time T is given as 2 hours. The next step is to define unknown. Find the average speed in kilometer per hour and in meter per seconds. Assumptions. The motion is uniform. The second assumption is the car moves in a straight line. And the third assumption is air resistance and frictional losses are neglected. Then the next step is to bring out a schematic. This is a schematic that shows how the car moves along a straight line with a distance of 120 kilometer. Then the governing equation and the governing law. The governing law is extracted from law of motion. And the governing equation that we'll be using to solve this problem is given as the average speed equals to distance over time. Analysis. Now we want to break down the problem by solving. We are asked to solve it in two different forms. Number 1, the average speed is defined as distance S over time, and distance S is given as 120 kilometer, and the time T is given as 2 hours. So when we calculate this, we have it as 60 kilometer per hour. The second one is to determine the average speed in terms of meter per seconds. Going by this, the average speed is given as 60 km per hour. We multiply the 60 by 1000 in order to take it to meter. Then we divide it by 3600. So the final answer becomes 16.7 meter per seconds. Now we have adopted the problem techniques that are used in analyzing problem. Example 2. A 2 kg mass of air is contained in a piston cylinder device at an initial pressure of 200 kilopascal and a temperature of 27 degrees Celsius. The air is compressed isothermally and the final pressure reaches 800 kilopascal. Determine the work done on the gas during this process. Take gas constant R to be equals to 287 joule per kilogram Kelvin. Solution. Step 1. Bring out the given data. Mass M equals to 2 kg. The initial pressure P1 equals to 200 kPa. Initial temperature equals to 27 degrees Celsius. The final pressure P2 equals to 800 kilopascal. Since the air is compressed isothermally, T1 equals to T2, which is the same thing as T, which is given as 27 degrees Celsius. Step 2. Define the unknown terms. Find the work done. Step 3. Bring out the assumptions. From the question. Assumption number 1. Air is modeled as an ideal gas. Assumption 2. The piston cylinder arrangement is frictionless. Assumption 3. It is an isothermal process. That is, constant temperature throughout the process. Assumption 4. The process is quasi-equilibrium. That is a reversible process. Step 4. Schematic. Here is a piston cylinder arrangement. This is the cylinder wall. This is the piston. As the piston compresses, there is a form of reduction in the volume and there is an increase in the pressure. Step 5. The governing equation and governing law. For an isothermal process, the equation becomes W equals to mRT ln V2 over V1, which is also the same thing as mRT ln P1 over P2. Step 6. Analysis. We look at the equation, we solve term by term. We solve for mRT, then thereafter we solve for V2 over V1. mRT equals to, the mass is 2 kilogram multiplied by the gas constant 287 multiplied by the temperature, which is 27 degrees Celsius. We need to convert it to Kelvin, plus 273 equals to 172.2 kilojoule. The next term is ln V2 over V1. But in this case, we are not given volume. We are given P, following Boyle's law, which states that P1 V1 equals to P2 V2. Then V1 over V2 equals to P2 over P1. Similarly, V2 over V1 becomes P1 over P2. Therefore, ln P1 over P2 equals to ln 200 divided by 800. And we have minus 0.25. Now, substitute the value of MRT and ln in this equation. The work done becomes 172.2 multiplied by minus 0.25. And the answer becomes minus 238.7 kilojoule. The negative sign in the solution of work indicates that the work is done from the surrounding to the system. Thank you for watching. Like, comment, share, and subscribe for more videos like this.